morning to everyone. So what I'm going to present now is just two examples to show what does it mean to bring some new technology on the market. So first, a brief presentation about Comau. Comau is a company doing industry lines automation, especially in the car industry. So we are part of FCA group, which is Fiat Chrysler Automobile Group, and this is the amount of employees we have. We are in 15 countries, 9,000 employees. We are 1.5 billion companies, and we are spread all over the world, especially where the car manufacturing is present. We have 5 innovation centers, and one innovation center is here in Tuscany, is at Pontedera. And we establish a very tight relationship with Scuola Superiore Sant'Anna. We started in 2015, and we also, our main purpose to be here is to make a technology transfer between what it is studied in Scuola Superiore Sant'Anna at university and into the industry. And I'm very proud that it was quite successful, what we did so far, because we acquired then the control of a startup company called Juvo in Comau now, and we are also one of the founding members of ARTES. ARTES is a competence center. There was an Italian, let's say, a law that provided to the building of 8 competence centers in Italy. One of them is here in Pisa, and we are one of the founding members. So just the main pillars in Comau. As I told you, we are doing manufacturing. So we have now in the process of digital transformation. We have robots, we have sensors, we process sensors, we have artificial intelligence in order to do predictive maintenance of all the production lines, to understand how the production line is going, how to improve the production line. But today I'm not, let's say, going in this type of details. I will show you something more relevant to collaborative robots and exoskeleton. Before doing that, I just want to mention about something which is very important for us, is about the education. Because it is fundamental for us also that people are properly trained and to give a proper instruction on what does it mean, the new technology. This is why we developed an educational package which is based on a small robot which is used for learning this technology at different levels. So I have a cluster, what we have in our, what we call education. It was Academy Lab, where we have for young talents, we are doing some masters internally in Comau and with the help of some universities in order to build up next manager generation inside our company. We also train external managers through some executive masters. Plus, we are also spreading this technology also at young people. So we have programs for different school levels, from kids from 8 to 19 years old. Because in our view, this is very fundamental that this young generation can really better understand the technology, to better understand the limits, and also to be less scared of application of this type of technology. So now I will show 2 examples of bringing to the market new technologies One is relevant to the collaborative robots, and the other is the exoskeletons. Both have a strong physical interface with human. First, the collaborative robots. So why collaborative robots are preferred in industry? So we have saving on plant space, because you don't need to have some fences to be built all around the robot. So this means also you have a lean setup. Is quick commissioning, because we have installed the robot. The robot is intrinsically safe, so then you can immediately start the production without doing any complex commissioning. And also easy interface to use, so you don't need to be an expert to be able to program a collaborative robot. So what about the regulations which are inside the robots, the collaborative robots? So we have basically two main norms. One is quite old. The other, this 15066, has been really created for the collaborative robot. So let's say when we started, we had only this one present. And we have 4 types of collaborations. One is the robot doesn't move when the man is there. There is an interaction, but the robot put the place, they work in the same area, but when the man is present in the same area of the robot doesn't work. The other is a speed limitation. When the more the man is getting closer to the robot, and then if it is too close, then the robot stops. And the other, the new one, is that we have a power force limiting, so then in case of collisions, of possible collision of the robot, in any case the collision is not dangerous and does not harm the human being. And this is given by this ISO technical standard, which I repeat, this technology standard has been put in place because of the collaborative robot. So then the collaborative was already present in some of the industry, but still the regulation was not there. So our basic approach was to use a standard robot and to cover this robot with sensorized skins. So on each of these skin is fully embedded with sensors and can detect the presence or not of a human body or also an object around the robot. So you see here we have different patches of skin, and each skin is completely autonomous, so that you can understand where the man is approaching, the human is approaching, compared to the skin, and so you can also take a strategy decision on what to do next in order to avoid collision or to do something else while the human is there. So to do that, so what we did, we are the only company on the market who have this technology applied to a huge robot of 170 kilo payload. And you can imagine this is a sort of dinosaur, because you see it's 2.8 meter, the reach. And in any case, what we are able to get the right certification of performance level D, which is the highest, and which is requested for collaborative robots. So this is just give you an idea of the sensor we have put on the robot. The skin structure is with different layers. We have a rigid frame, which adapt the shape of the robot to the skin, and then a sandwich of sensors, where we have proximity and touch sensors. So then when the robot, when the human being is approaching the robot at 20 centimeters, so the robot can detect and they can stop. Also in case of contact anyway, we have some redundancy. In case of contact, the robot stops. And in addition, we have also a foam which can be able to absorb energy in case of impact. So this is what we have created some sort of redundancy in terms of proximity, contact, and the passive foam. What we did here, we did some analysis. We have used some software that they are using the crash test for in the automotive industry. In order to, because the purpose here was to size the foam of to be put on the robot and to evaluate the speed in order to be below the limits given by the new ISO 15066. So about the certifications, we had to do 2 parallel certifications. One was for the skin alone. So I'm not going into all these details, but it was just to understand about the redundancy, reliability of what the technology we have used. And this is we have done with TÜV Sud. But what happens is that just to be clear, a collaborative application is not a matter of code. So you can have a collaborative robot, but it doesn't mean that the application is collaborative. Because you have the robot, but you have the end effector. And if you put a knife on the end effector, so this can be dangerous. So this cannot be a collaborative application. The same also that if you have a cobot, it doesn't mean that always you don't need fences. Because if with a cobot in some part of the task, you have to handle dangerous material, in this case, you have to take all the right precaution in order to avoid any possible harm of the human being. So, in all this case, really depends on the applications. So, what we have done here for the application, we have done some real tests of the robot in order to be sure that if we hit some of the parts of the body, we are below the requested limit. So because depending on the application and depending, you can imagine if I hit a man on the head, it's different if I hit on the breast. And then depending on the application, you have you can go at different speeds. And the other was TÜV Rheinland. So we had to do this with 2 different third-party certifications. Plus, as I told you, it was not solely sufficient to cover the robot with the skin, but on the application, you had to consider the end effector and the payload that the robot is transporting. So then we had to put some force-torque transducer in order to detect possible impact with the payload. Operator protection, because if the payload or the end effector has some parts which can be dangerous in case of hitting the human being, so you have to cover the end effector as well. Plus, we have to consider also the economic aspects in case you have to drive the robot with manual guidance. So here are various examples on, you see, this is with the handle, and this is covered. And you see also in this part, you touch, you stop the robot, and you see we had to cover the complete end effector to avoid damage to the human being. plus you have also, just to show you some effects in terms of collision detection and also hand guidance. You see, this is, it took about 1 year for us to do just the robot certifications from the proof of concept. So quite a long time before you can go on the market. Now, the second step is about the exoskeleton, because this is collaborative robot, what I showed you before. Now, this is wearable robotics. This is something which has more, some way more impact on people, because this is something you dress on. Just to, because it was already mentioned before that we have the fiction is already providing some concepts about the exoskeleton. Well, we are very far from the fiction. So I want to show you first what we have considered this exoskeleton. I show you a video, so then you can understand what do we mean about the exoskeleton or wearable robotics. There are a lot of problems for people doing this type of operations, because after a certain time they have some musculoskeletal problems, and so most of them they have a sort of permission, not medical permission, not to do this task anymore, and so the company has to convert these people to do other type of tasks. Which is causing some problems. This is not only the automotive industry, this is general in all industries. And the fact that we are able to reduce the work fatigue with this type of device, we have other type of benefits, is also that we can improve the quality of the operation. Because we did some tests, and after a while, that the operators is working in certain conditions, let's say the accuracy is reduced. With this type of device, you can keep the same level of performances for a longer period. So I want to stress that so far there are no regulations on the market for the exoskeleton in the industry environment. So for the industry, there is no regulation, and this is why we set up a team, because we as Comau, we are doing robotics, we know very well how to industrialize the product. But for example, we were not familiar about how to dress a robot to a person. This is why I think we put together a team, which is Comau for the industrialization and for the commercialization of the device. We involve Ossur, which is an Icelandic company. I will show you one slide of them, which are market leader in prosthesis. And plus Juvo, where there is a very high knowledge in terms of designing mechanical devices for the exoskeletons. So here is Ossur, is BBVio, is one of their ambassador, and before it was also Pistorius, but after the last event, they removed from their website. Okay, Comau, I just skip. Plus we have Juvo. This Juvo is a startup of the Scuola Superiore Sant'Anna, is now fully controlled by Comau, and in 2 years we passed from 8 to more than 50 people involved. Now we are still growing, and we are thinking to be 30 for end of next year. So this is the exoskeleton, is quite a huge market where there is a lot of interest, and we believe in this type of opportunity. So the development approach. You see, we started from the reference tasks of workers working underneath the car, and we had a workshop with them in order to define all the requirements. And also we asked them what could it be. We asked to draw some sketches and also to build a sort of prototype. So, and after we have several interactions with the same worker, because we did first workshop, then we built the first prototype, and then we go through a series of iterations to get their feedback and to improve the design to make it acceptable for them. As I told you, there is so far no regulations about the exoskeleton. So then for us the first was to have an acceptance from the worker side, because they had to use for a long term, and this is why we did this type of approach. Okay, these are the various technical features. I repeat, this is a totally passive device. So we have no actuators. We have a third generation box, which has basically some springs that can help when you have the arm at 90 degrees compared to your shoulder. We pay attention to the materials, to the soft goods, where we put attention in terms of breathability was one of the key issues. Regulations, because we have 2 sizes, but each size have a lot of regulation, because you have to understand that a human body can be quite different. And so, because one worker can have the belly, the other is very tall, so then we have a different type of requests, and so this is why we did a lot of regulations. And one important thing is that also we put a lot of attention in providing what we call passive degree of freedom. So then we are able to reproduce completely the movement of the shoulder, which is one of the most complex joint of the human body. Okay, this is just again what I was just telling you before. Okay, this is how it works. So it can provide the maximum assistance when you are 90 degrees between your arm and your trunk body. Is proportional, so the assistant when you are close to your body, the assistant is 0. The more you go up with the arm, the more increases its assistance. Now, what we have done in terms of test or certifications, as no real regulations is present currently for the exoskeleton. So first we did some laboratory tests in order to understand the type of improvements for some tasks the exoskeleton can bring at the various operators. And we have some questionnaires, and we measure sometimes. We have static, so for how long it could take a certain load with or without the exoskeleton, or for material handling, to put one object from one plane to another. This is the accuracy test. They have to follow a certain path, and so with or without the exoskeleton. And so let's say basically it was to understand for how long you can keep the same performances after a long time, and some real test simulating the operation underneath the car. We had also a cognitive psychology involved in the team, because we had to understand also the reaction of the worker. So this at the end was the result of this type of test. Most were positive, and so especially in terms of perception or reduction of fatigue. Of course, some of them, you see, some of them are taken positively, some of them less, because you have to add something additional on your body. What we have also done, we have, this is not a medical device, I want to stress, but we wanted as Comau to be sure that when we put on the market something does not cause any problem, long-term problem to the workers. So this is why we did some specific tests at a rehabilitation clinic center in Italy, which are mainly, their focus is for rehabilitations. And this is a research center. This is a research center too. And they have all the protocols and all the instrumentations in order to be able to measure and to analyze all the data. Again, this has been quite positive, because we did with electromyography, with cameras for kinematic postures and everything. And we had, let's say, the results has been better than what we expected. And we had an average reduction of more than 30% on all the subjects. I think we tested around between 15 and 20 subjects. So I repeat, this was not requested by the market. This was something we as Comau wanted, we put in place in order, let's say, to put ourselves on the safe side for possible claims. What we did, we involved also a third party for the CE mark, and so far we identified these two regulations. One is machinery directive. It's not really a machine, it's a passive, but as you have some springs, so there is an article of the machinery directive referring to this type of devices. So then we consider it. And also we consider the ISO 13482, which is mainly for personal care robots. Here it is mentioning something about the exoskeleton, but it's not specific for the exoskeleton. Okay, That's it for my side. Thanks.